Hey friends, it's Miss Winship. We are going to now learn to solve systems of equations by elimination. We have to solve the systems of linear equations in two variables by elimination. We have to compare and choose an appropriate method. We're actually going to compare and choose an appropriate method tomorrow. So write this equation down. We are going to solve this by elimination. Now the word elimination means to get rid of something. So looking at this problem, I notice that if I draw a line underneath, oh shoot, come back. All right, notice that if I draw a line underneath here, if I try to add these together, the 2y and the y add up to 3y. The 3x and the negative 3x cancel, and that gives me 12. Well, I can solve that. Dividing by 3, y equals 4. All right, this is working pretty well for me. This is called elimination because the 3x and the negative 3x must eliminate. Now I have y equal to 4. I'm going to plug it into the easier of the two equations. To me, that looks like it might be the first equation. So I'm going to rewrite the first equation. Y plus 3x is negative, goodness gracious. Y plus 3x is negative 2. 4 plus 3x is negative 2. Move the 4 to the other side. 3x is negative 6. Divide both sides by 3, and x is negative 2. Then I need to write it as an ordered pair, negative 2, comma 4. So the key to elimination is actually eliminating two variables. Let's look at another one. Write down example 2. Sometimes when they have the same term, you can subtract one equation from the other equation to solve the system. Number 2, go ahead and write it down. Now in this one, if I draw a line underneath, I notice that the 3 y's are not going to actually cancel. If this 3y was a negative, they would all cancel. So what I'm going to do is change all of the signs on the second line, which means I'm subtracting the two equations. Adding going down, I get 5x, cancel, equals 20. Divide both sides by 5, and x is 4. Easy squeezy lemon peasy or something like that. Now I need to take the x equal to 4, plug it back into an original equation. 3 multiplied by x plus 3y equals 15. Since x is 4, I'm going to plug in 4. 12 plus 3y is 15. Moving the 12 to the right. 3y is 3, and divide both sides by 3, I get a 1. Now writing the intersection point as a point, I get 4, comma 1. Good job. Some cases you will need to multiply one or both of the equations by a number so that the variable has opposite coefficients. Now we're going to have a brand new step 1. All right, let's look at these two. If I tried to cancel the x's, I couldn't just change the sign because 3x doesn't cancel with 1x. If I tried to cancel with the y's, again, those do not cancel because 2y cannot cancel with 1y. But what I can do is multiply the top one by a 3. That's going to make them eliminate. Draw a line and let's see what happens. 3x plus 6y is 33. Negative 3x plus y is negative 5. Okay, the 3x's cancel. I get 7y is equal to 28. Divide by 7 on each side, and y is 4. Now I'm going to plug the y equal to 4 back into an original equation. I like the top one. X plus 2 times the y value equals 11. Since y is 4, I'm going to plug in 4. X plus 8 is 11. Solving for x, x is 3. Writing it in an ordered pair, these two lines intersect at 3, 4. Example 4. Now I really have a problem. There's no way I can get these two to cancel, even if I multiply one of them by a number. There's no way I can get these two to cancel, even if I multiply them both, or multiply one of them by a number. So what I think I'm going to have to do is multiply them both by the same number to make them cancel. For instance, if I tried to make these two x's the same, I could take this 2, multiply the top one by a 2, multiply the bottom one by a 5. Now notice I did not put -5, I just leave it 5. Now that's going to make that a -10. This one's going to be a +10, and then they will cancel. Let's try it. So 2 times -5 is -10x. Now I can't just multiply the first number, I also have to multiply all of the other terms of my equation. 2 times 2 is 4y. 2 times 32 is 64. Now we're going to do the 5. 5 times 2x is 10x. 5 times 3 is 15y. And 5 times 10 is 50. Now these are going to very easily cancel. 10's cancel. 15 and 4 is 19y. 64 and 50 is 114. Divide both sides by 19. You can use a calculator if you like. And y is going to be 6. Now this part is always harder on the plugging it back in. I'm going to take the 6. Which one looks easier? I don't know. The bottom one kind of looks easier to me. I'm going to take the 6 and plug it into the y. So 2x plus 3 times the y equals 10. And in place of the y, I'm going to put a 6. 2x plus 18 is 10. Subtract 18 from each side. 2x is -8. Divide both sides by 2, and x is -4. Writing the solution as an ordered pair, the x goes first, the y goes second. All right, you ready for some more fun? Number 5, strange example. Let's see what happens here. Well, these are kind of out of order for elimination, so I think I need to move the 3x over to the left to make them in standard form. I also noticed that this 2 is in the wrong space, and I think it needs to be over to the right. So when I move the 3x to the left, it becomes -3x plus y equals 2. For the second equation, I'm going to leave the 3x and the y, and I'm going to move the 2 to the other side, which makes it a -2. Solving by elimination, I notice that the 3x cancel. So I cancel, and I cancel, which gives me a 0. The 2 and the -2 also cancel, so I get 0 equals 0. Well, 0 really does equal 0, so these lines, not only do they never intersect, they always intersect because they are the same line. And the way you say that they're the same line is you say that they intersect infinitely many times. Infinitely many. All right, word problem. Number 6. Paige has to buy $7.75 to buy 12 sheets of felt. The felt is 50 cents a sheet and the cardstock is 75 cents a sheet. Okay, how much money does she have? She has $7.75. She needs to buy a total of 12 sheets. She is going to buy felt. She's also going to buy cardstock. So I'm going to put felt and cardstock down for both of those. Okay, now on this top equation, it is taking into consideration the cost of the felt. The felt costs 50 cents per sheet, and the cardstock is 75 cents per sheet. The second equation is only talking about the number of sheets, and so I don't have to put the cost in front of those. Okay, now at this point, if you had your calculator, you could just type it in and find the intersection point. Since you're at home, we have to work it all out. All right, let's go. It's not that hard. All right, so I'm going to multiply the bottom, how about by 0.50? So that gives me 0.50. I'm rewriting the top equation equals 7.75. The second equation is 0.5f plus 0.5c equals 6. Now, I notice that these don't cancel, so I'm going to have to change some signs. I'm going to change my signs on my second line. Opposite, opposite, and opposite. The F's now cancel, and I get 0.25C is equal to 7. Sorry about that. Make that $1.75 because that's $7.75 minus 6. $1.75 divide by 0.25 on each side, and C is going to be 7. Now I need to plug it back in. Definitely the bottom equation looks easier. So F plus C is 12. F plus 7 is 12. Subtract 7 from each side, and F is equal to 5. Okay, so what that means is she needs 7 sheets of cardstock and 5 sheets of felt. All right, you did it. The end. Good job. Tune in for more later. Bye.